Welcome back to this YouTube tutorial series on implementing generics/templates in C. And in today's video, I'm going to be going over some basic examples of void pointers and pointer functions. And towards the end of the video, we're going to be going over an example of the QSort function given in the standard library. So to begin with, we're going to import standard IO. This is going to be used for print out statements, and the standard library just for actually calling malloc. So to begin with, we're going to make an integer, and we're going to make an int pointer. It's going to point to the address of my int. Okay, and then we're going to make a double, 3.4. We're going to make a double pointer called b. It's going to point to the address of the double. And then also, we're going to make a structure. So now we're going to actually make a structure that can handle both integers and doubles. So we're going to say struct user defined, and we're going to say void data. So now we're going to make a structure that has a void pointer, therefore it can handle almost any kind of input, any kind of data. And then what we're going to do is we're going to make our struct here user defined. We're going to make it a pointer. We're going to cast a pointer on a malloc. So now we're going to allocate memory onto the heap for our struct. I can type it out. And what we're going to do is we're going to set our data first to the integer pointer, and we're going to print it out. So we're going to say printf integer, %d is the parameter for printing out integers. And then what we have to do now is take our void pointer data inside our structure and cast that back into an integer. So we're going to say int pointer of our C data, and remember we have to dereference our pointer, so we're going to add another star to dereference it. So here we have our void pointer, and it can take up any kind of value. So all it does is it just points to the starting memory block, and whenever we cast it back into an integer, it knows how many blocks of memory that the data took up. So now we're going to change it. Actually, let's run this. So we have incompatible type, user defined, layout integer 5. All right. Now what we can do is we can change our data, our void pointer, to point to the double instead of the integer. And %f is the type parameter for doubles. And just like in our integer, we're going to have to cast it first into a double, and then we're going to have to dereference that to get the actual value. So here we have our integer and our double. And another thing we can do is we can actually make another void pointer. We're going to call it myVoid. And it's going to actually take our user-defined struct and translate that into a void pointer. So now what we can do is we can take another print out statement. So we're going to say printf double from void star of struct. So we're going to take this void pointer here, myVoid, we're going to cast that back into a user-defined struct, and then we're going to access the data and then reference that back into a double. So as we just did, we took our C data and we casted it into a void pointer of a double. So here what we're going to do is cast that back into it. The first thing we need to do is take myVoid and cast that into our user-defined struct of my void, and then now we have to actually get the data parameter. So we're going to include a parentheses around this, and then we're going to get the data, and then we're going to convert that into our double pointer. And since we want the value, we're going to dereference it. And so one thing I forgot to do is actually have a free statement. So here on line 120, we actually allocated memory using malloc, and we want to free that memory at the very end. That way we don't have any memory leaks. There we go. And a cool tool we can actually use for memory leaks is a program called Valgrind. And this is a very simple tool, and I think it's used on Linux and other software, operating systems except for Windows. So we can do valgrind a.out, and it's going to tell us how many allocs we had, how many frees, how many bytes were allocated, and if any leaks were possible. So here it says no leaks were possible, but let's say, for example, we were to comment out that free statement. It would show us, oh, we have two frees, two allocs, one free, and if we compile our code with the .g parameter, it compiles it into a form that allows us to actually check out exactly which line number occurred. So we can run Valgrind again, this time except with leak check equals full, and it shows exactly on what line. So at line 120, we forgot to free this data, free this memory. So here, this is just a cool tool to use Valgrind on our software, on our program. So here in this structure, we've actually defined an elementary form of a template. It can hold almost any kind of data type you want it to hold. And before we end this video, we're going to go over the qsort method, which is available in the standard library. So the qsort method is going to have three parameters. First, it's going to require a pointer to the start of an array or just the start of a linked list. It's going to require also the length of the linked list or the length of the array, its size, and then a comparator function. And in this instance, it's actually accepting a pointer to a function. And so we're going to actually implement an example of a pointer to a function. So to begin with, we're going to make a simple array. We're going to say values, and we're going to say, let's say 1, 2, 3, 4, 5. And then what we're going to do is we're going to make a simple comparator function. Except let's actually make this out of order. 4, 1, 2, 5. So we're going to say integer compare const void star left, const void star right. So here we're using the constant keyword because we actually do not want to change any of the values of the left or the right. And so we're passing in numbers. So we actually want to dereference these, we want to cast these void stars back into integers. So what we're going to do here is we're going to say integer L is equal to left, integer R is equal to the right. And then what we're going to do is we're going to say if dereference L is larger, less than integer R, we want to return -1. Else if dereference L to get the value is greater than integer R, we want to return 1. Else, that means we have a match, and we're going to return 0 on a match. So the whole purpose of the qsort function is to sort the data, and you can do this for any kind of data structure. So if we had an array of structs and we had an ability to sort them on either like name or index, all we had to do was to just create a comparator function and then pass that into qsort. So here we have our values, and now what we're going to do is we're going to say qsort values and 1, 2, 3, 4, 5. So we're going to pass in 5 as our size. We're going to do size of int because that's our value, and then we're going to pass in our pointer to our comparator function. And then this should sort the values. I'm going to say for integer I is equals 0, I is less than 5. We're just going to print out the values. So here we have this. I'm going to clear this out. We're going to compile our program. We're going to run our program now. And it seems we might have reached an error, so we're going to run a Valgrind. Oh, forgot to save. So compile it, run it. As we can see, it sorts our function. So the qsort function is an extremely useful function in the standard library. So today what we went over was actually just introducing basic concepts of void pointers and how it was able to actually be able to hold integer pointers, double pointers, and as you can see, multiple types of pointers. So we even created a new pointer called myVoid that was able to cast our struct user-defined pointer into a void pointer. And then we can dereference that pointer. As we can see here, we can get the data by then dereferencing it back to a double, and then dereferencing it again to get its value. And so this allows us to make a basic template for C using void pointers. And then we went over pointer functions using the comparator function for the qsort. So qsort requires a simple pointer function, and we made one here called compare. So here, when qsort needs to call the function compare, it accesses the pointer, which points to the following code here. So this is extremely useful, especially in extending the reusability of our code. So in the next video, we're actually going to implement a stack data structure using all of these elementary ideas and expounding upon them. So stay tuned.